Okay, good morning, everyone. So my name is Siva. I work at Autodesk as Customer Success Manager within our digital twin product called Tandem. In today's presentation, I'll be briefly talking about building lifecycle management and how digital twins can play a crucial role in enabling this process while also leveraging this approach to deliver benefits to the industry. So building lifecycle management approach considers building's entire lifespan, covering all phases from design to demolition. In this approach, data becomes a valuable asset, offering critical insights throughout the project lifecycle. By emphasizing the continuity of data throughout the asset's life, we gain valuable insights that enhance decision-making, optimize building performance, and contribute to objectives such as sustainability and social well-being. While cost is often considered as a primary driver in the AEC industry, this approach also considers other important aspects such as environmental, sociological, cultural factors, among others. So why is adopting a BLM or a building lifecycle management approach so crucial? To understand this, we partnered with IFMA, and there we saw that we introduced a diverse set of owner-operators. The findings were quite revealing. A significant 85% of owner-operators grappled with issues related to fragmented data and compromised data quality. And probably because of this, 95% of the engineering and construction data goes unused in operations. This data fragmentation and quality issues also translate into further challenges, including financial impact, environmental consequences, and asset depreciation. These problems are largely, if not maybe predominantly, due to the absence of building lifecycle management approach to data. However, there is an opportunity as around 96% of the FMs or facility managers believe they can benefit from access to the design and construction phase data during operations. So some of the benefits that we can leverage by using this approach during different phases of the buildings are listed here. For example, during planning phase, you can use this for long-term efficiency by integrating operational insights into the initial design phase. Likewise, there are benefits during the other phases of the building lifecycle as well. However, coming to some of the challenges that are there in implementing or adopting this approach include, for example, fragmented data. Data is often siloed across different teams and disciplines, and because individuals tend to take a short-term view and focus narrowly on the specific scope or phase of work. Also, there's a need to embrace data-driven approach in the AEC industry and invest in upskilling the workforce. A lack of strong mandate or incentives is also another reason, although I think with the golden thread requirements emerging from the Building Safety Regulation Act for England, I hope will certainly encourage the industry to adopt a BLM approach for data management. Technology is also a barrier, particularly for those who are not familiar with or involved in the BIM process, as they cannot contribute due to lack of access to the software or the skills to work with it. And these are some of the steps I think we can take to encourage adoption of a building lifecycle approach, starting with advocacy for standards, then trying to invest in skill building, maybe trying and also doing some ROI models that will show the value of the building lifecycle management for those sitting on the fence, while pilot projects will offer practical examples of how integration and data continuity can improve building performance. Each of these steps, I think, is crucial for driving the adoption of a building lifecycle management approach. So now let's look at how digital twins enable and leverage this approach. Everyone in this call is familiar with digital twins. I won't go into the definitions of those. But I think digital twins pave the way for building lifecycle data management by creating a digital thread or golden thread of data continuity. Digital twins facilitate the maintenance of a digital record of essential building information, starting from the design concept phase and continuing throughout the building's lifespan, thus enabling building a lifecycle approach. Digital twins also simplify the technology complexity by offering an easy-to-use web-based interface, eliminating the need to download or master complicated software. As a result, they enable a broad spectrum of stakeholders to participate at the relevant stage or phase of the project. They foster increased collaboration among a diverse group of stakeholders, integrating building lifecycle approach through different phases of the built asset. Furthermore, a digital twin facilitates early involvement of stakeholders, which promotes informed decision-making. This early engagement and enhanced interaction fosters trust in the data, minimizing the delays during data handover and improving the upstream usage of data. During the planning and renovation phase of capital projects, this data is readily available or accessible for the planning team to make insightful and data-driven decisions, thus helping realize the benefits of building lifecycle approach. Now let's look at some examples. So I'll quickly share my screen. So this is an example of a digital twin, just a simple browser-based application. This is one of our offices in Birmingham. To add the data to a digital twin, all that you would need to do is point to the location of the data, either on your servers, or if you're using a common data environment platform, you can just point to that, connect to the data there. And then if there is an update available for that data set, you get a notification right here in the digital twin. You simply click on this update button. It'll compare what has changed from the version in digital twin versus the new updated version, just brings in the data, and that's all. Your digital twin is updated with the latest data. Once the data is here, then the digital twin is doing a lot of things behind the scenes, but you can filter the data. For example, in this case, if I want to filter the data using any of these parameters, I want to see the data on ground floor, so I can just click on it. But this is the power of the data. So once you're following a lifecycle approach and using a data-driven approach here, I have these 100-ish parameters defined during the operations phase of my building operations, and I can use any of these parameters to query my digital twin. But the good thing about here is the data continuity. So I also have around 2,000 parameters on which information was collected during the planning, design, construction, installation phase. I could use any of those parameters as well to query my digital twin. So now I see I can query the data by assets or by room sizes. So this is one good example of showing how you can have how you can use digital twins to have this data continuity or golden thread or digital thread of information. But another good use of digital twins that support this concept of PLM is around how we can enable wider participation. So for example, you could expose a view like this, and let's assume a scenario where someone is coming to install these machines in the shop floor. Typically, what they can do is they can install the machine. They can just click on it because this is just a web-based browser. They don't need to know any software for this. And they click on an asset. They add the information for this asset. That's all. It's as simple as that. They can attach documents. They can attach videos. They can attach pictures, whatever. They can also use tabular views if that makes things easier. They can also import, export data from Excel files, for example, to speed up the process. Once this is done, as an owner-operator, what you could do is you could use dashboards, built-in dashboards, to check for the data completeness. Here you can see a full list of parameters, but here you can see the data for, let's say, the vital parameters or important parameters. And this is all live, so I can go here and change the level or filter criteria, and I can see how the data is changing for those things. So this is how you can continuously build up the data into your digital twin as the project is progressing and by the people who are responsible for the data. The other thing what you can do is once you move into the operations phase, you can augment this digital twin with additional data. For example, in this case, because it's a workshop area, we have installed sound monitoring sensors to monitor the health or to ensure the working conditions are good. And with this digital twin, we can monitor the sound levels. We can see the trends over a period of time and so on. So this is helping us to define a baseline, create a baseline, and then take some corrective measures and see if whatever actions we have defined, are they working or not working using digital twins. And it's a data-driven approach. So whatever decisions you're making are validated by the data.
30 seconds left, Siva.
Okay, yeah, so I'll just switch over to my PowerPoint, back to my PowerPoint here. So in addition, if you have the BIM data, what you can also do is you can leverage the BIM data, for example, to do this kind of trace analysis. So this is again leveraging the data BIM data during the operations phase. So these are some of the examples. If you are interested in any of these, please feel free to reach out to me. Thank you.
Siva, our next question is, what file formats does Tandem work with? Is it able to use IFC for the model, or does it rely on proprietary data formats?
Yeah, so Tandem currently works with popular formats such as Revit, Navisworks, 3D CAD files. But of course, it also works with vendor-neutral formats such as IFC. So there's a full support for IFC as well.
Very good. Thank you very much. Next question here is, how would you define fidelity in this context?
Well, I think fidelity and also data frequency, right? Both of these are critical parameters for digital twins. And both of these actually are defined by what is the purpose, what is the use case. So use case and the outcomes you are expecting from your digital twin will define the model fidelity and also the frequency or cadence of your real-time data, I would say.
Very good. A couple more questions for yourself, Siva, if I may.
Yeah.
Is an interesting question here. How does Tandem compare to other proprietary digital twin solutions, such as Space's Twin Viewer or Bentley's iTwin or other platforms as well?
Yeah, I would say, there are a lot of digital twin solutions in the market, and every digital twin solution has its own pluses and minuses, I would say. From Tandem perspective, we take the approach of BIM first, as in the AEC industry that has already invested in BIM, but we find most of the data is probably used during design phase to some extent, to a large extent, I would say, and to some extent during construction phase. And then we notice it's hardly used during operations phase. So our inspiration, let's say, for investing in digital twin technology is to help the people who have invested in BIM, how can they leverage the benefit into the operations phase, which is where we know, most of the buildings' life cycle is spent. So that is our emphasis, and then our emphasis, how can we then make things easy to connect with other smart tech that is typically used in a building environment. So that is our focus, and I'm sure other solutions have their own focus, and I would say it's up to the users to evaluate what are their use cases, what are their outcomes, what are their reasons for using digital twin, and then select the technology appropriately.
Very good. Thank you. And the final two questions here I'll ask you as a kind of combined question.
Yeah.
How challenging is it to manage an asset for the entire life cycle in such a fast-moving and changing industry? And is it possible to do single sites rather than across a portfolio?
So I'll answer the second one first. So currently we do single sites, but portfolio management is on our roadmap, and that's the current feature we are currently working on. And for the first one, of course, it is challenging. I won't say it's an easy thing. And as an industry, we're trying to solve that problem. We know buildings are not static. Buildings are evolving. Buildings are changing. And I would say that is still an area of challenge. But with the developments that are happening in the scan to BIM technology, for example, and the automations that are happening in that space, I would expect we'll have better technical solution soon. But today, yeah, it is still a challenge.
Very good. And our final question here, if I may, so for yourself, is how do you get data streaming from the assets?
So we support a lot of industry standard protocols like BACnet, like MQTT, like Modbus, and we also support streaming data from Azure IoT Hub, for example. So it depends on the technology. Some of them could be out of the box, as in zero code solutions. Some of them may require some coding solution. So all of the possibilities are there, and that is one of the strong features that we are working on to reduce the technology barrier for integrations with the different IT/OT systems.